Hello, everyone. Good morning, good afternoon, and good evening. Thank you for taking time and being here today. It is wonderful to have you all for our webinar, Bridging OPC UA Data to Azure Cloud with MQTT. Today's webinar is presented by Kudzai Manditereza, who is the founder of Industry 4.0.tv. A very warm welcome to you, Kudzai. Accompanied by Kudzai is Ravi Subramanian, Director of Industry Solutions at HiveMQ, who will be helping with the Q&A. Before we get started, I would like to share that we are recording this session and all participants will be on mute. We will share the recording as well as the slide presentation later. If you have any questions, feel free to type them in the Q&A pod, which is there in the control panel below. If there are any questions that goes unanswered, we'll either get back to you later or you can submit them in our community forum. Lastly, during the Q&A, we will run a poll, request you all to participate. Now, without further ado, I will hand it over to Kudzai. Welcome, everyone.
Thank you so much, Jayashree, for the introduction, and I would like to welcome everybody that is in attendance today. Thank you so much for your time. Okay, so today I'm going to talk to you about bridging OPC UA data to Azure Cloud with MQTT, and I'm going to follow up with a live demonstration during this talk. So without further more to do, let's get started. So again, my name is Kudzai Manditereza, and I'm a technology communicator and founder of Industry 4.0.tv. I'm involved in various efforts, which include Industry 4.0 research, creating educational videos on Industry 4.0, and I also host an IIoT podcast. I've got a background in embedded systems design, software engineering, and also industrial automation. So you can reach out to me on the social media channels that you can see on the screen there. Okay, so the question is, why would any manufacturing company want to send OPC UA data to the cloud? So as a matter of fact, manufacturers produce large amounts of data. In fact, the volume of data that gets generated in some factories can reach terabytes in an hour. But the unfortunate part is that much of this data that could help improve the productivity of manufacturing plants and the quality of goods produced goes unused, mainly because up until recently, there hasn't been tools or platforms that make it easy for you to harness this data in order to extract the required insights. But today, with Industry 4.0 technologies and platforms, it has become easy and less costly to capture this industrial data and use powerful and sophisticated data analytic tools to dig into the data. Now, the fact is, those data analytic services are not native to a factory floor. They live in the cloud, where they are backed by data storage platforms that can ingest as much data as possible. So you can think of your Amazon Web Services, your Google Cloud, and Azure Cloud. So the idea here is to collect real-time and historic data from your PLCs, your machines, SCADA, historians, and so forth, and push it to the cloud, where you can then use those data services to extract insights that could significantly change the way you operate a manufacturing business. Okay, so maybe to kind of put things into context here, here's a list of example applications that you could build from industrial data that is sent to the cloud. So these include asset monitoring, which could be used by plant managers to monitor the health of industrial equipment across an entire manufacturing enterprise. You could also build process dashboards that could be used by process engineers to find correlations between parameters and track things like your KPIs across different plants, which they can then go on to use to optimize the industrial processes. And you could also build things like your overall equipment effectiveness applications for production or operations managers to assess the effectiveness of industrial equipment that's been used in production in a production process. And then one of the most popular advanced analytics applications, one that you may be familiar with, is predictive maintenance, where you could automate the analysis of data collected from industrial equipment and sensors to detect anomalies and predict equipment failure. So this really presents an unprecedented opportunity to reduce downtime and increase the utilization of your production machines. And then finally, you could also use the collected data to build apps that you could use then to present a forecast of different parameters or events in a production process. Right, okay, so we've discussed why you need to send OPC UA data to the cloud and the kind of industrial IoT analytics applications that you can build on top of the data. However, there currently exist challenges in integrating factory floor-based OPC UA systems with cloud-based analytics. Right, so now most of those challenges, they mainly emanate from the client server, or what you'd call a request response model of communication when you're using OPC UA. So this is whereby an OPC UA server exposes information about an underlying device or machine. And when an OPC UA client needs to read the information, it does so by sending a service request to which the server responds accordingly. Essentially, there is this direct and synchronous communication between an OPC UA client and server. Now, that model of communication works fine in closed loop command and control kind of industrial automation scenarios where you have, for example, a field device integrating other applications at the edge or within a factory using a dedicated network of communication. And in most cases, it's where the total number of connections is not very high. Now, that in as much as that works in an edge environment, when it comes to the context of integrating factory floor OPC UA data with cloud-based components, this OPC UA client-server communication approach falls far short of what is expected. So the first challenge is that using an OPC UA client-server communication model, some form of agreement or handshaking has to be established between the server and a receiver before any data can be sent in either direction. So that includes things like deciding which protocols to use, what encoding to use, and what security mechanism to put in place. Now, due to the requirement of this sort of persistent underlying communication layer during OPC UA client-server interactions, it makes it difficult to use OPC UA in IoT devices that have limited memory and computing power for storing the connection information and for encoding the individual messages per established connection. And yet, we know that for applications such as predictive maintenance, you need to be able to retrofit your machines with tiny sensors that transmit data to the cloud. So that becomes a challenge as far as integrating those tiny sensors to the cloud using OPC UA client server model. Secondly, when you're using an OPC UA client server communication approach, it's difficult for cloud-based analytic systems that know nothing about the OPC UA platform to gather data from production components that talk OPC UA. And this is clearly a big problem because currently the data analytics tools that do not talk OPC UA happen to form a large part of the cloud ecosystem. And third, while the OPC UA client-server approach allows for the exchange of any type of information in a flexible manner, it comes at the expense of a lack of real-time communication between the factory floor and the cloud, of which we know there's some analytics applications that require you to actually provide an answer within a time-critical or within millisecond latency. So that isn't something that is not available with a client-server communication approach. And lastly, and perhaps more importantly, is that as the number of connected components increases rapidly in industrial IoT scenarios, the OPC UA client-server communication model cannot scale to meet such connectivity demands. That is, its need for a direct connection between sender and receiver becomes impractical when an OPC UA server has to share the same data with, say, thousands or even millions of other systems, as is expected of a fully fledged Industry 4.0 system. So what is the solution here? So the solution to these challenges is to bridge OPC UA with MQTT. And by bridging OPC UA, I don't mean necessarily replacing OPC UA, because we still need the OPC UA client-server model to take care of synchronous communication at the edge. And then we can have MQTT act as the interface to the cloud because it has the characteristics that enable it to do so efficiently and in a scalable manner. So maybe let's take a few moments here to understand the basic concept of MQTT that make it suitable for factory floor to cloud data transmission. So this is a diagram that shows an MQTT network. So as opposed to the client-server communication pattern, MQTT is a protocol that uses a publish-subscribe pattern of communication. So this is whereby the participants of the MQTT network never contact each other directly. In fact, they do not even need to be aware of each other's existence. The connection between them is handled by a third party called an MQTT broker. So all applications, which could be like a PLC or SCADA system at the factory floor, or it could be analytics application in the cloud, these are called clients, and they have the capability to send and receive messages through the broker. So when a client is sending a message, it is called a publisher, and when it receives a message, it is called a subscriber. So the job of the broker in this case is to filter all incoming messages and distribute them correctly to subscribers. So here, essentially, all direct communication is totally removed, and thus making it easy to merge data from control systems with IT systems in the cloud without them having to know anything at all about each other's implementation details. So if you like to learn more about MQTT, you can check out the MQTT Essential series on the HiveMQ website, right? So for now, let's briefly discuss the benefits of MQTT that make it suitable for factory floor to cloud scenario, right? So first of all, MQTT is lightweight, which makes it possible to deploy on tiny sensors that have limited computational resources. And as I've already mentioned, this is important in applications where you would want to retrofit sensors on existing equipment and have them publish information about the health of the asset directly to the cloud. And secondly, because in an MQTT network, there is no direct communication between the sender and the receiver, it means that you can add as many participants to your solution as possible. MQTT brokers such as your HiveMQ broker can manage up to millions of connections, so which is actually useful in an industrial IoT scenarios where you could actually, you'd want to have a provision of scaling to as many connections as possible. And then next, because MQTT uses data encoding technologies like JSON, it makes MQTT data compatible with cloud-based data services that also understand JSON, right? So also, because MQTT is like super fast, it makes it possible for analytic systems to effect a change fast enough in situations where there's time-critical applications, right? And another thing is that MQTT is useful for transmitting data from industrial facilities that are located in remote places where the network might be unreliable, such as in oil and gas and things like that. And then finally, MQTT has got a security enabled. Okay, so we've discussed the usefulness of MQTT in interfacing between OPC UA infrastructure in the factory floor and the cloud system. So what are the options that you've got available to you for integrating MQTT into your OPC UA infrastructure for the purposes of sending the data to the cloud? So the first option is to use a gateway that serves as an OPC UA client to collect data from the OPC UA server on one end, translating it to JSON and publishing it to a broker using MQTT on the other end. So that's option number one. So let's look at the pros and cons of this approach. So the advantages of using this approach is that there is a wide range of OPC UA to MQTT gateway tools to choose from. Some of them are hardware solutions, some of them are software solutions, and you could even build your own using programming language SDKs provided by the OPC Foundation, and some that have been developed independent of the foundation. And this obviously gives you the flexibility to program the gateways in the manner that you want, right? Now, the disadvantage of that setup is that you have to keep some ports open for the OPC UA client to access the server, because if you're using a gateway, what it means is that the gateway and your server have to be on the same network, a subnet as it were. So you'd have to have a port open for the client to access that server. And as you know, this is a security risk because you can have unwanted inbound connections exploiting those open ports. So that's something that you wouldn't want to let happen. Also, if you have to use a gateway, then you'd have to apply some sort of engineering effort in terms of network design. And also if you have to use a programming language, you have to do the actual programming. So there is an engineering effort that is involved with actually going that route. Right, the other option of integrating MQTT into your OPC UA infrastructure is to use OPC UA PubSub model of communication. So let me give you a brief background on what this really is. So what happened is that the OPC Foundation realized that they realized all these client-server communication challenges that we've been discussing so far. So what they did is that in addition to the client-server communication model, they came up with a specification that enables you to use a publish-subscribe pattern of transmitting data from an OPC UA server. Now, unlike a gateway, this is a functionality that you build into the OPC UA server itself as an extension. So the PubSub functionality lives inside the OPC UA server. It's not an external feature like having a gateway on a subnet. And then you can then use some tools to configure that PubSub server. So what are the advantages of using this OPC UA PubSub approach when you are interfacing, when you are bridging OPC UA data using MQTT? So when you're using OPC UA PubSub, the server effectively becomes an MQTT client. And what that means is that the OPC UA information source becomes the one that initiates communication with the cloud. And therefore, there's no need to keep any ports open, which is a great advantage from a security standpoint, based on what we have discussed in a previous slide. And because you have direct connectivity to the cloud from the OPC UA device, it means that you reduce the number of components in your data pipeline, right? So instead of having a server, having a gateway and many other components, you're actually reducing that to only one component, because having a lot of components in your data pipeline could actually compromise the integrity of your data. So you'd rather have the server publishing directly to the cloud as a single source of truth. Then you know that you're actually getting data with integrity. Now, the advantage of OPC UA PubSub is that it is a relatively recent specification, and therefore there isn't a lot of systems out there that implement it as yet. Also, because it's an inbuilt extension, there is limitations to what you can actually change. And also you need to have some special tools to perform some configuration of the OPC UA PubSub functionality. Okay, so as mentioned at the beginning of this talk, I'm going to be showing you a live demo of bridging OPC UA data to Azure Cloud with MQTT. So first of all, let us take a look at the architecture of our demo. Okay, so what I've done is I've deployed a HiveMQ MQTT broker cluster on Azure, and I've enabled the HiveMQ extension for Kafka so that you can forward all those MQTT messages from the broker to Azure Event Hubs. And Azure Event Hubs itself being a hot storage mechanism on Azure, which you can use for queuing and retaining your messages. So I've also provisioned an Azure Time Series Insight service to ingest this data from the Azure Event Hubs and then visualize that information. And then I will be publishing OPC UA data to the HiveMQ broker using the two methods that we've just described as far as bridging OPC UA data with MQTT, so that you can witness both approaches from a technical standpoint, right? So in the first setup, I've built a .NET Core application that acts as an OPC UA client. So I'm actually using an OPC Foundation UA.NET SDK. So in that application, I'm essentially reading simulated data from a Kepware OPC UA server and converting it to JSON and then publishing it to a HiveMQ broker. So we're going to get to the code in a bit. And then in the second setup, I've put together an OPC UA server with a PubSub extension, which implements the OPC UA PubSub model that I've just described. So this is using actually a Node OPC UA, which is a full stack implementation of OPC UA, including its PubSub models, and that is all based on Node.js. So I've also got an OPC UA server that I've put together in Node.js that is using this stack to actually create an OPC UA PubSub based server. So I'll be publishing the OPC UA data from this server as MQTT messages to our HiveMQ broker on Azure Cloud. Okay, so I guess it's time for our demonstration. So I'll switch over to okay, so first of all, how do you go about deploying a HiveMQ broker cluster on Azure? So you can actually go to this HiveMQ GitHub repo, and you can see here there's this button that says deploy to Azure. So if you click on that button, it will take you to your Azure portal, where you can then fill in some basic information about your deployment, and then everything will be done automatically for you. So I'll go to my Azure portal here. So I've done that already. I've deployed a broker cluster that's composed of one node. So you can actually have more nodes if you want to have like a redundant system, so that if one node fails, you could actually have other nodes take over. So for demonstration purposes here, I've actually deployed a HiveMQ cluster broker using only one node. So here, if I go to the OPC UA PubSub demo resources, so here you can see some of the services that have been provisioned for me when I deployed that. So you see we've got our load balancer that has been deployed. We've also got a virtual machine, which is node 0. So if I had more than one node here, you'd see node 1, node 2, node 3. So because I've only got one node, so you can see that I've got a node 0 virtual machine. And so my deployment went successful. So to check that it actually is successful, I've actually got a HiveMQ control center that I'm accessing at this IP address, which is the IP address of my broker, right? So that's the IP address of my broker cluster, which you can actually get from your load balancer public IP settings in Azure, in your Azure portal. So now, the advantage of actually having a control center like this, when you've deployed your HiveMQ broker on Azure, is that you can actually get information about the traffic of your MQTT clients as they communicate back and forth. So you've got this visibility within your solution where you can actually see how many connections are present, or much more details. There's also an analytics section here. So this is something that isn't available when we're using something like Azure IoT Hub, which is sort of like a black box. So that's an advantage of actually deploying a standalone broker on HiveMQ. And also, not to mention the fact that with Azure IoT Hub, it is an MQTT broker, but it's a special kind of MQTT broker. So it's only meant to actually work with Azure. So it doesn't fully implement an MQTT specification. But if you have a broker like this, then you know that you've got a broker that's fully compliant with MQTT. So you can do things like your Sparkplug and all other different things, which is actually beyond the scope of this talk today. So I'll just go back to my Azure portal here. Okay, so going back to my portal here, under the resource group here, so I've put all the resources that I've created under this resource group. Okay, so here under this resource group, this is where I've also created an Azure Event Hubs service, right? And I've called it OPC UA MQTT demo. So you can see that's my Azure Event Hub service here called OPC UA MQTT demo. And if I click into it, right, so if I click into it, so you can see there's the Azure Event Hubs queue, which is called HiveMQ inbound. So now here, what you need to take note of is this name of the queue, because we're going to be using it in our HiveMQ Kafka extension to actually configure our HiveMQ Kafka extension to forward all the messages to these event hubs. So another thing that I need to mention here is that HiveMQ Kafka extension is able to actually send messages to Azure Event Hubs, because Azure Event Hubs and Kafka use the same format of ingesting data streams as it were. So I've also created an Azure time series insights. So you can see here, I've got a time series environment called OPC UA MQTT demo TSI. So we're going to be actually going into that later on in this demo. Okay, so what I want to share with you here is a party. Okay, so this is what I've used to actually SSH into the virtual machine that is hosting the HiveMQ broker cluster, right? So now what I've done here, I've actually navigated into the directory that contains the Kafka extension. So I'll just go ahead and open up that configuration file. Okay, so here you can see there is the name of my event hubs, OPC UA MQTT demo. And then here I've also got the connection string, which actually points to my Azure Event Hubs. And then here I've got the HiveMQ inbound, which is the queue that is going to be ingesting all of these messages that are coming from my HiveMQ broker. And then here you can see I'm specifying the topic for which all the messages are going to be forwarded to the Azure Event Hubs. So if I'm going to be publishing to this topic, and all those messages that are coming on this topic are going to be forwarded to the Azure Event Hubs. Okay, so now I'm going to open up my Visual Studio Code. So this is where I have got the code for actually implementing the OPC UA PubSub server. Right, so, okay, so here I have got my Node.js application that imports Node OPC UA, right? So that's the package. I've already installed it here. So, and then here I'm also importing another package, the Node OPC UA PubSub server. And then I'm also doing a lot of other bunch of imports. I think you're going to have access to this code after together with the recording of this video, so you get a chance to actually take a look at all the different imports. Okay, so what I've done here is I've created a server, right? And then I've added an object, called it my sensor. And then here I've added a variable called temperature, right? Which is of double data type. And then here I'm simulating the value of the temperature. Okay. And then if we go down here, you can see here is where I'm specifying my MQTT endpoint, right? So this is the IP address, if you remember, of my HiveMQ broker cluster on Azure. And then this is also a bunch of other configurations. This is your dataset writer, which is part of what you'd actually need to put together if you're implementing this. And then here at the bottom, you can see this is where we've got our the node ID of the temperature. So automatically, I've actually configured this to this PubSub extension to collect this temperature sensor node, this temperature sensor value from this node, and then publish it as MQTT to my HiveMQ broker cluster. And then here you can see I'm specifying the topic name, which is Hive MQ demo / telemetry. So let's go ahead and run this application. So this is where, so that's the directory of my server. So this is the application here, server.js. So we're going to run this. Okay, so my server is running. So what it means is that my OPC UA PubSub server is now actually publishing information to my Hive MQ broker cluster on Azure. So we can actually confirm that. So to do that, I'm going to use a software called MQTT.fx, which allows us to actually connect to the same broker cluster and visualize all this information. So if I go to settings here, you see I've got the same IP address. I'm pointing to the same broker. Okay, so I'll go ahead and click on connect. Okay, so you see it's turned green, so which means we've successfully connected to the broker cluster. And then I'm going to subscribe to the same topic here. So if I click on subscribe, there you can see we're getting our information from the broker that is being simulated by our OPC UA PubSub server. So this means that we actually indeed are publishing this information to our MQTT, Hive MQTT broker cluster on Azure. So here you can take note of this property message type. It's called UA Data, because I'm actually using that as a partition key in the Azure time series insights, right? So now we can actually go to Azure time series insights. Okay, so this is my Azure time series insights. Okay, so here you see we've got this UA data. And then if you click into it, you can see we've got this payload sensor temperature that is coming through. Right, so here you see we've got our information. So I could actually zoom into this. So you see we've just actually started publishing that information now. So we'll get back to this. We should be having a nice trend going on there. Okay, so now I'm going to go to my KEP server, right? So now we're going to option 2. Now we're going to be publishing from our gateway. So our PubSub is working. So now we need to go to our gateway. So here, just to show you here, I've got, okay, so I need to reconnect to this. Okay, so that's my KEPServerEX. So that's actually running. So here I've got some simulated examples. So this is where I'm collecting all of this information. And if you check here on the configuration manager, you can see that we've got our server here, and then this is the server endpoint that I need to connect to. So now let's go to my Visual Studio Code to actually see my gateway code that I'm using to collect information from this server. Okay, so now I'm on Visual Studio. So this is the gateway code. So this is where I'm using the OPC UA .NET SDK to actually create an OPC UA client. So this is acting as an OPC UA client that is reading information from our KEP server at this using this node ID, right? And then here I'm also connected to my HiveMQ broker using this IP address, which is the same IP address that we're using for all the other instruments, right? So now here, there's something that I need to point out to you is I'm actually creating a server. Okay, so here is where I'm actually specifying the endpoint, my server endpoint. So you can see here that's the actually the host name of my PC, and then here we've also got a port. So this is where also you see that we need to be accessing this OPC UA server at this port. So I've had to actually allow this port connections on this port on my firewall. So that's a security risk. So now once I've read that information, and then come here, I'm creating a JSON object. So here I'm creating sensor temperature. I'm creating from that ramp value, which is the simulation of our temperature. And then here, so I've got a message type. So remember in our previous, in our OPC UA PubSub option, we actually have UA data as the message type property. So here I've got it as gateway data. That's my message type property. And then once I've built that JSON string, I'm then publishing it to this HiveMQ telemetry topic. So we can go ahead and run this application. Okay, session is created. Okay, so now we're publishing information from our gateway to the HiveMQ broker. So we can also confirm that by going to our MQTT.fx software. Okay, so if we subscribe to the HiveMQ broker cluster, you can see that we are getting the information from both UA data and also from the gateway data. So we are receiving actually messages from two clients. One is an OPC UA to MQTT gateway. The other one is an OPC UA PubSub server that is pushing information directly from itself. So let's go back to our Azure Time Series Insights to see what sort of trends have we got. So here I can choose to add also information that is coming from this gateway. Okay. So we're going to give it a few moments and then we'll start to see information coming through. So maybe while we wait to do that, so there's information from a previous test that I was doing here. So you can see there we've got information that is coming from UA data. And then here we've got information that is coming from gateway data. So this is an analytics platform in itself, and you could actually use it to perform a lot of different data analytics operations. You can do your average, you can create models, you can do so a lot of other things. So let's go back and see if we started to receive that information. Okay, so you see, we started to receive information coming from both the UA data and from our gateway data. So that actually brings us to the end of this demonstration and this presentation.
Thank you,
over
Kudzai.
to you, Jayshree.
Thank you. Thank you so much, Kudzai. It was a wonderful presentation and demo. I think now I will hand over moderating the Q&A to Ravi. So
yes.
Yes. So before,
thank you, Jayshree.
Yep.
Go ahead, please.
I will start the polls. So request you all to participate. And Kudzai has also covered a blog post on sending OPC UA data to Azure. You guys can also check out in our blog section. You will find that blog post. I will start the polls and you can start the Q&A, Ravi.
Thank you so much, Jayshree. Kudzai, what a wonderful presentation and demonstration. Always very insightful. And
thank you.
Like the audience learns, we also keep learning new things from your webinar. So thank you so much for that. So okay, so let's start with the some of the questions that came through. I did answer some of them, but of course, like if any of you have any further questions that you want to ask based on the responses, please feel free to add that. The first one is obviously there's some feedback that, hey, this is quite overwhelming. It's a lot of information. We do understand that this is kind of like a little more advanced, right? We kind of like assume that you already are in OPC UA, you're using OPC UA and you're looking to go to the cloud. So obviously that's this demonstration, but we actually have a lot of basic content available on the HiveMQ website, right? I mean, the MQTT basics or Sparkplug basics to get you started. We can certainly share that information. I think that's from Fanello. We'll certainly share information with you after this webinar. So you can kind of like get the basics and then you can come back to this obviously for more information. That's great. All right. The next one is, what requirements are there for an MQTT broker to support OPC UA PubSub? A specific version of MQTT, Sparkplug, etc., or can any MQTT broker work with OPC UA PubSub? Kudzai.
Yeah, so any MQTT broker can actually work with the MQTT with the OPC UA PubSub, because the PubSub is essentially there isn't any semantics, any special kind of semantics within the OPC UA PubSub data. It's pure JSON. So any MQTT broker that can handle a JSON payload can actually handle OPC UA PubSub information. So, but just to mention something there, there's also a possibility. Suppose you are publishing from an OPC UA server to another OPC UA application, right? So now you want to sort of maybe maintain the semantics of the information. You can actually use some configuration tools to actually do that, to publish that sort of information. But still, that information will still be in a JSON format. Only the publisher and receiver would know how to interpret that at the respective ends. Right.
And Kudzai, when you and I were talking, you also mentioned that it's essentially like a MQTT client at this point, right? It acts as an MQTT client, which obviously we can take data from any of the MQTT client coming into the broker, right?
Yeah, absolutely. And also maybe just to linger on that a bit, by default, OPC UA PubSub doesn't use MQTT. It can use things like your AMQP, but obviously there's a disadvantage obviously to using AMQP. There's an advantage of using MQTT in this instance. So it's not something that is unique to MQTT.
Yeah, and there was actually a couple of questions on that, right? Why not use AMQP or MQTT? I did publish some comparisons in terms of the payload size and other advantages that MQTT offers over AMQP. But if there's any further questions, please do ask. But back to this question, I know Kevin Niemler, you asked this question. I hope we did answer this question for you. If you want to kind of like seek any further clarification, maybe Jayshree, you can unmute Kevin. And if he wants to ask any further questions, he can do that. Does Kevin? Did that answer your
I
question,
have
Kevin?
unmuted you. You can actually start interacting. Cool.
Yeah, that was a great answer. Thank you very much for that.
Okay, thank you so much, Kevin. I appreciate it. All right.
Thanks, Kevin.
All right. Matthew Venter asked a question. Could you please explain a bit more regarding Kafka and how it connects to the broker and streams data to the Azure Events Hub? Kudzai,
Okay, so in this setup, we don't have a Kafka, right? What we do have is a Kafka extension. We've got a HiveMQ extension that is built to actually forward information to a Kafka cluster, right? But we don't have Kafka in this instance. So what we actually have is an Azure Event Hub service. So these two, a Kafka cluster and Azure Event Hub, actually operate in the same manner. They actually use the same way of actually representing the topics and queues and stuff like that. So basically, if we could actually point that Kafka extension to a Kafka cluster, it would actually act the same way that is actually acting even now when we're sending to Azure Event Hubs. So the Kafka part is only actually responsible for pulling data from the broker and forwarding it to what it seems, what it thinks is a Kafka cluster part. It's actually an Azure Event Hubs service.
Got it. And obviously you use Kafka if you want to do streaming analytics, right? Versus some other Azure services if you want to do some other use case.
Yes,
right?
yes, absolutely.
Okay, wonderful. Matthew, I hope we answered your question. Matthew Venter. If you have any further questions, Jayashree, if you can help unmute Matthew.
Matthew, I've given you the permissions to talk.
All right. I guess we'll take your silence for we answered your question. But if you do have any further questions, please feel free to reach out to us or ask on the Q&A. Matthew, thank you so much. All right. So moving along here, Mohammed, who also asked, I think the first question that Mohammed asked was like, can we publish this the code that you use for the demonstration to GitHub? That was the first question he asked. And then the second question is like, the OPC UA server that we're using, is it it's KEPServerEX or is it another Node.js application?
So there's two OPC UA servers. So I think maybe we went over this a bit too fast. So we've got two OPC UA servers here. One OPC UA server, the one where I'm actually demonstrating the gateway scenario, is a KEPServer OPC UA server. So I'm using that KEPServer OPC UA server in conjunction with the .NET Core application, right, which is an OPC UA client. I'm reading information from that KEPServer and publishing it to the HiveMQ broker in a sort of like a gateway kind of setup. And the other server, I've got another server, which is a Node.js server. So that Node.js server is actually an OPC UA PubSub server that is publishing information directly from itself. That one is not using a gateway. So we've got two servers here, one Node.js and the other one is a KEPServerEX server. All
right, that's a good answer. The first architecture you showed was the KEPServer architecture, right, where you have the gateway, and then the PubSub architecture is the new Node.js architecture. Great. Mohammed, I hope we answered your question. If you can, again, Jayashree, if you can unmute Mohammed and see if we answered. And thank you, Matthew, for responding on the chat, for like acknowledging that we answered your question. Mohammed, if you don't mind saying, did we answer your question? Do you have any further clarifications to say?
I think it's still on mute.
Is he? Okay. Yeah, Mohammed, you're still on mute. If you want to unmute yourself and ask any further question. All right.
Thank you. Thank you.
Okay. Okay. Did we answer your question?
No, thank you.
Okay, I appreciate it.
What about the source code? If you could send the source in the GitHub, yes. I will put a project.
Yes, we'll look into it for sure. All right, thank you, Mohammed. Okay, Finello Lambi is okay. So yeah, we answered your question. Okay, okay. So David Margaret's as for the comparison MQTT OPC UA for real-time communication. Can you explain that further? I think a comparison of MQTT versus OPC UA for real-time communication, if we could explain that further.
Okay, so yeah, so well, MQTT is a very lightweight protocol, right? And because it doesn't have a lot of overhead as far as having to maintain a connection. Because with the OPC UA client server, what you need to do is you've got to actually perform some handshaking of some sort, right? And then you've got to maintain that communication. Though the client and server have to agree what encoding mechanism they're going to be using. They've got to agree what protocol they're going to be using. They've got to agree on the security. So that's all of that information that needs to be carried or that needs to be put together in setting up that connection. So with MQTT, there isn't any of that. So the MQTT, the packet, I think it's I can't remember the exact size, but it's very tiny as far as the comparison to a client server connection is concerned. So MQTT is fast and it's faster than OPC UA. So the idea there of OPC UA PubSub is to then use the MQTT as the transportation mechanism to prepare that OPC UA object, but not use OPC UA as far as the communication is concerned. You hand over that information to MQTT, and then MQTT handles that communication. So that's why also there's actually things like OPC UA for field bus communication to try and replace your field bus protocols. That is actually the research is going on with OPC UA PubSub, not with OPC UA client server, because of that fact that the PubSub is much faster than the client server approach.
Okay. David unfortunately had to leave, so he's not here to ask any further questions, but I believe we've answered that question, and I've asked him to send more clarified questions if he has any, if we haven't already addressed it. All right, so we'll stick with that. Saravana Kumar asks, does time series model indicate plotting the data in time series insights? Is this question. The time series model.
Can you come again?
So basically his question is, does the time series model indicate plotting the data in time series insights? Does the model indicate that we are plotting the data in time series insights? Does that make sense, or?
It's not very clear. It's not very clear.
Maybe if Saravana Kumar is available, he can, if you can unmute him and he can clarify the question. Hello.
Yes.
Hi, Saravana Kumar, you're on. If you can just clarify your question for us, please.
So what are the parameters I'm taking from the field? So those data can be displayed as dashboard parameters in time series insights with respect to time. Does this the function of time series model?
Yes. So basically, time series it's a way of actually displaying your telemetry data with respect to time. So it's the time series kind of trend that you put together when you do that. So maybe with regards to the models that you asked about, to say within time series insights, you can actually create a model. Because for example, right now I've got temperature that is coming from a gateway, and I've got another temperature data that is coming from a PubSub, but these are discrete parameters. So within time series, you can actually build a model that identifies to say this temperature is actually, you can actually add semantics within the time series insight, so that when you actually navigate it within the time series insights, you can go into an object and say it's a boiler. You can actually go into a boiler and then say this is temperature A, this is temperature B for boiler. You can get that kind of model within time series insights. So I'm not sure if it exactly answers your question there.
Yeah, this answers my question. Thank you.
Thank you, Saravana Kumar. All right, so next, Praveen Kumar Pitala is asking, is Node-RED node supporting OPC UA server PubSubs? Can we use Node-RED for this?
So, well, I don't know of any packages that do that, but the fact that we actually have a Node.js, which is essentially JavaScript, that is supports that, it means you could literally just port that to your Node-RED. So technically it does support, because we've actually witnessed it actually happening with Node.js. So you could actually do the same and port it to Node-RED. So technically it's possible, but I don't know of any packages that do that yet.
All right. Hopefully we answered your question. I know we are short on time, so I will let you kind of like post another question or reach out to us if you have any further clarifications. In the interest of time, we'll keep moving on. We have 3 minutes, so let's try to address as many questions as possible. Okay, David is not available. Okay, so is there a similar setup that will work with AWS? That's the question from a gentleman named Git lead better.
Yes, so that's the similar setup actually that would work with the AWS. The only difference is that with AWS you won't have Azure Event Hubs. So you've got to have find an equivalent of Azure Event Hubs, something that is capable of ingesting a Kafka formatted kind of payload. So as far as deploying the broker, actually with HiveMQ, you can deploy a HiveMQ cluster on AWS. What then differs is the data services that are behind that broker. With Azure, you've got your event hubs, you've got your time series insights. So with AWS, then you've got to identify those data services that will be able to actually consume that information and actually visualize it. But as far as the architectural setup is concerned, it should certainly be more or less the same.
Okay. Here is another question. Does it make sense to use Sparkplug with an OPC UA PubSub?
So, well, something that is not supported, right? So that's certainly something that is not supported. So, I mean, I'm sure you could actually implement that, but the OPC UA PubSub doesn't support Sparkplug. It supports the MQTT, it supports AMQP, and then it also supports UDP. Right.
Okay. Understood. Okay, I don't know if Abdallah El Mautier is available. He asked us to unmute him so that he can ask the question.
Yes.
If you could help. Yes. Yeah.
Thank you for taking that question. I got a quick question. I know this is all about HiveMQ, but is there a way we can publish the MQTT straight to the IoT hub?
Yeah, so I think I touched a bit on that in the demo to say IoT Hub is essentially an MQTT broker, so you could publish that information to an IoT Hub.
Okay, all right, that answers the question. Thank you. Appreciate it.
Okay. There's a question here. The gentleman is not available, but we can still ask since we have a minute. And what field did you use for the timestamp in TSI? Have you seen any problems with aligning the timestamp from the sensor collected data to Azure? Is the question.
Okay, so as far as the timestamp, I actually in setting up the time series insights, I actually configured it to actually use the timestamps within the time series insights environment itself. I could have chosen to use the timestamp from the payload, but I did not. So when you're configuring your time series insights, you can actually choose to say what timestamp do you use. Do you want to use timestamp that comes with the payload, or do you want to use the timestamp that actually comes that gets assigned to that payload as soon as it is incident on that environment?
Right. Okay. I think we answered all of the questions. There was one question that came on the chat directly that we may not have addressed. Yeah, is the .NET OPC UA to MQTT network program code available for public use? I think that some other gentleman asked the question too.
Yes, so all the code that we've actually been demonstrating here on this talk, will make them available to anyone who's interested in actually going through them, if that's the question that they're asking. But also the SDK that I used in that .NET Core application is actually free to download from and install.
Okay. Yeah, here is a last question that I answered, but I would like you to also answer. Does the analytics work in real time? I mean, sensor delivers data very fast and I want to perform analytics in real time, right? What's your take on that, Kudzai?
Yeah, so it actually works in real time. I mean, in my experience with MQTT, when you actually, as soon as you send information, it's there. It's lightning fast. It's really fast. So it works in real time. So now it depends on the application, but that's
right, exactly. Yeah, that's what I said. It depends on the application. There might be some latency, but yes, I mean, it's not discernible, right? You should be able to see your output in near real time. Yep.
Yes.
I think those were the questions that I saw. I think we answered a lot of questions live. A lot of questions have been already answered. There was another message. Hold on, just 1 second. All right, there was a lot of people said great presentation and thank you for the demo. So I think over to you, Jayashree. I think we are done here.
Yes.
Yeah.
Thank you so much, everyone. Hope the session has been really useful. Thank you so much for all the feedback and the questions. So if you have more follow-up questions, we are here to help. Get back to us anytime, and we will be sending out follow-up email. We'll be sharing useful resources and links which you can use. We will be also sharing the recording of the webinar as well as the slides. You can have access to it and you can watch it at your convenience at a later point. So thank you so much for presenting, Kudzai. Thank you so much, Ravi, for helping with the Q&A, and thanks everyone. See you all next time.
Have a great week, folks. Bye. Thank you. Bye-bye.
Bye-bye.
Bye.